Welcome everyone to the Microsoft IoT Deep Dive. Today we are going to deep dive into Azure Digital Twins for smart buildings. And we'll do that by deep diving into the WillowTwin solution. My name is Pamela Cortez, and I am the IoT Developer Advocate and Community Manager here at Azure IoT Product Team, and I focus on improving the Azure IoT developer experience. I will be answering your technical questions in the live chat. If you're viewing on demand, we will highlight at the end where you can go to ask your follow-up questions. So let's go ahead and jump into this. I'm excited to introduce our special guest speakers who will be sharing their expertise in this area. So joining us today, we have Rick, who is the product and engineering lead from Willow. Willow is one of our top partners. So thank you, Rick, for joining us today to do this deep dive.
Yeah, thanks, Pamela. Excited to be here. At Willow, I work on advancing our user experience with both our internal and external developer community, and specifically focus on our partnership with Microsoft and our journey to implement Azure Digital Twins and really all of the Azure IoT stack.
Awesome. Thank you, Rick. We really appreciate you taking your time out and joining us in this deep dive. And then we're also joined here by Alina, who's my colleague here on the Azure IoT team, focusing on Azure Smart Spaces and energy.
Hi, everyone. Thanks, Pamela, for having us. I'm a senior program manager, as you said, in Microsoft at Azure IoT Smart Places and Energy, focusing on smart building ontologies as well as edge scenarios, like reducing building onboarding by applying machine learning to classify the building management system data. I'm also an Azure IoT Digital Twins pioneer. I have worked on the platform since early days and continue to work with our customers like Willow to accelerate their end-to-end solutions built on digital twins. And today, I will be talking about our partnership with Willow, especially now as Azure Digital Twins is GA and Willow being a GA launch partner, and share with you the results of our collaboration over the last 3 years.
Wonderful. Thanks, Alina. And I love that both of you are here. I know you've been working with Azure Digital Twins for a long time, so it's great to have your expertise and share your insights while we're going through this technical walkthrough. So for today's show, it's all about Willow, the global technology company that has offices all around the world, how they're leveraging Azure Digital Twins in the WillowTwin smart building solution. So here at Microsoft, Alina just said, we just announced Azure Digital Twins is now generally available. What that means is that it's ready for large production scale development or deployments. And Willow, as Alina mentioned, is our GA launch partner. And so we'll go through one of their solutions deployed on one of the Brookfield iconic building, 1 Manhattan West in New York City. So for today's deep dive, we're going to do a walkthrough with multiple personas. So if you are, let's say, a property owner, you'll get a glimpse on why Willow is a great partner for building smart building solutions. If you're a facility manager, you'll learn about the fault rule engine, which is all about reducing operation costs in you get to see the 3D visualization of building systems. If you're a solution architect, you will learn about WillowTwin architecture and what are the services used. And then if you're a software developer like myself, you will learn about the behind the scenes making of WillowTwin. So we'll get a deep dive of the architecture, the modeling, data importers, backnet importer, and much more. And Rick will explain why Azure Digital Twins is a game changer and the benefit it provides. So Rick, before we get started, do you want to just quickly go over high level what the demos you're going to be showcasing today?
Yeah, absolutely. So to start off, we're just going to show a brief demo of the actual WillowTwin in action. So the user interface and a short kind of day in the life journey. And then on the back end of that, we will focus on the actual developer experience. So jumping into VS Code, looking at some of the ways that we leveraged the Azure Digital Twins SDKs and what it's been like working with the Azure Digital Twin platform.
Okay, wonderful. Thanks, Rick. To start us off, Alina, do you want to go over why Willow, why the WillowTwin solution before we dig into the demo?
Yeah, absolutely. I'm so excited to introduce our audience to Willow today, a partner that has been on Azure Digital Twins journey since the beginning, very beginning. Willow has demonstrated a great commitment and partnering with us as we develop the platform. They have provided us critical feedback and lots of learnings as we progress towards GA. And of course, there are so many reasons why we chose Willow as a launch partner. I will just talk about some of the reasons here. First, they are very agile and forward-looking partner. They are a digital native player in the smart building industry, leveraging Microsoft technology, which is such a great innovation. They have a deep understanding of the markets they serve, and their portfolio of the customer is impressive. And today, as you mentioned, we'll be taking a closer look on one of the amazing customer, which is Brookfield. And second, as you can see on my screen, there are lots of great features in their solution. And I'm just starting with visualizing their customer portfolio in one global view, modeling, of course, with DTDL, building an automated pipeline from BIM to Azure Digital Twins, lots of interactive 3D experience, which allows operator to navigate their building systems, time machine for live data and historical trend logs, actionable insights, which could generate tickets, fault rule engine, connectors like edge connectors like BACnet, OPC UA, just to name a few. And last, but of course not least, it's a marketplace. It's a rich library of third-party applications which could be integrated into their platform. And third, they're using a large number of Azure services, IoT Hub, Digital Twins, Real Estate Core. We just launched our ontology of models recently. IoT Edge, Azure Stack Edge. They are running their connector, the Edge connectors on Azure Stack Edge. Stream Analytics, Azure Function, ML, you name it. There are so many, and Rick will walk you through the architecture so you understand the data flow starting from devices all the way to the dashboards. And now I'm inviting Rick to talk about all of these features, and especially about the ones that are not so visible, but they make a huge impact on our customers, like security and data isolation. And later he will have followed by his demo of the WillowTwin.
Yeah, thanks, Alina. So Willow really serves as that digital platform for the enterprise's built environment. So today we're going to be looking at how that applies to the real estate community. We've got similar products and platforms built for other industries, all built on that same digital twin technology on top of Azure Digital Twins. Our goal is to take all of this disparate data that comes from many different sources and organize it and make sense of it, and then present it, surface that data to the end user, so they can take actionable insights, streamline their workflows, whether it's from the operations staff to the tenants, really driving that occupant experience. Behind the scenes, one of the things that Willow always leads with is security. So while it's not a focus of today's presentation, I just wanted to mention that we're very proud to be ISO 27001 certified as of 2 months ago. And a lot of our customers are actually selecting Willow because of that security layer. All of these disparate systems that they have deployed throughout their environment, it's really hard to make sure that they aren't poking any holes necessarily in their firewall. And so they can rest assured that when they deploy Willow, having that secure tunnel from the edge to the cloud, any systems that are connected to Willow acting as that true middleware, they don't have to worry about necessarily all those various vendors having security issues. And one of the great things about, again, us being built on top of Azure is we can quickly and rapidly scale not only that security, but also the infrastructure.
Great. Well, we're really excited to see that first demo, Rick.
Great. Yeah. So let's jump on in. Today, we're going to be looking at the what we call our command platform. It's geared towards the operators and facility staff of the building. And we're going to look at sort of how all of this data gets presented and organized in the platform. All right. So this is the, as Pamela mentioned at the outset, one of our flagship customers, Brookfield Properties, has a new iconic tower in Midtown Manhattan called One Manhattan West, which is on their broader Manhattan West campus. This is the kind of just the dashboard landing page as you navigate into a portfolio view into that per site view. If you're operating an actual facility or site, experiencing how you can interact with all this data that's coming in from various sources. So on the left here, I have a kind of skeleton outline of the building. You can see here that different floors are actually lighted up, indicating to you as the user, different areas you might want to go investigate to either optimize your operations or notifications are coming in. A lot of those are triggered by what we call insights. So insights are generated from a number of different sources. We have native sources that can trigger insights through our inspections tool. They could also be triggered by an alert or an alarm coming in from the live data platform. And then through our marketplace, where we connect to a wide variety of third-party best-in-class providers of software, we're able to trigger insights as well. So in the case of this building, we're connected to a fault detection and diagnostics platform where we send them live telemetry from the building. They perform their analytics with that data. And if a rule or a fault gets triggered, they send it back to our platform to allow the actual operations staff to take an action. So in the case of this building, it looks like if I start to dive in here, we actually have an outside air sensor that has crossed its threshold. I can see here it's actually been triggered by our native ruling engine, which we'll talk about in a little bit. If I look at a few others examples, you can see here where I'm actually received an energy optimization insight. So if I'm looking to reduce energy in my facility, it looks like potentially great savings greater than $1,000 per year. I can start to investigate how I can adjust this exhaust fan, which has been triggered by the fault detection platform. And then the third item that I mentioned was our inspections tool. And so as operators are performing their daily rounds and weekly rounds, making sure that the facility is operating smoothly. If they notice something that is out of tolerance, it gets flagged in the platform and you can create an insight. All of the insights that are generated here can be actually actioned into what we call tickets or work orders. So it really streamlines how the operations of the facility can much more efficiently allow users to get access to all of this data and perform the work that they need to do to make sure that the facility doesn't become uncommissioned or out of tolerance. So let's dive into an example here. I'm going to jump to the fourth floor here. It looks like it's lit up red, something for me to investigate. The first thing that I'll notice is I'm actually landing on a 3D view. And so it's one of the things that I wanted to talk about today, just in terms of digital twins, is there's a lot of demystifying, or what is digital twins? What does it really mean? At Willow, we like to think of digital twins as really a combination of a lot of key data sets. So not just the 3D geometry that we see here, but the actual spatial asset documents and live data that are coming in. They all play a part in the digital twin. And really what we're going to explore later in the show is how all of that data, which is this intricate web, especially at a building as complex as this, how it can have these complex relationships so you can really take advantage of finding the data as quickly as you can and determining root cause analysis and figuring out how some equipment might be affecting other equipment, or how one tenant, their experience might be impacted by other aspects of the building. So I've just flipped on here the HVAC layer model. And so you can see the complexity of the ducts running here. I'm going to focus in here on the bottom right-hand corner. This is actually an air handling unit, the one that was actually had an insight on it. And so if I want to find out details about it, all of this information is being pulled from the twin, this metadata. If I want to start to look at the telemetry, I can quickly jump here and look at telemetry based on the last couple of days, or if I want to look at how it's been trending for the last week, you're able to look at that through this time machine type view. And if I want to look at any associated tickets, I can see here that this has actually had a couple historical tickets related to it that I can go investigate. Maybe the current problem is related to a previous issue. All of this data is it's connected, and that's the beauty of the underlying Azure Digital Twin. Is the graph database topology really allows us to drive insights and allow the user to access this information much more quickly than having to go to many different disparate platforms to find it. So I'm going to back out and take a look at the 2D experience here. So same as the 3D. But we can see here that I'm pulling in the same information, but the 2D experience is more of a CAD type layer. So if I pull on my same layer, my mechanical layer, I can start to see how the pipes are routing to this piece of equipment, which again, it's lit up red because it has that outstanding insight on it for us to investigate. And if I want to generate an insight or a ticket for someone to follow up on, as I mentioned, it looks like here I've got some discharge air temperature sensors kind of going up and down, and I want someone to go check out why that's happening. I can actually just do a quick screen capture here. Save the image, and it gets added to my my shopping cart or my image inventory here, where I can actually action a ticket for someone on my staff or a team member to go look at. And again, all of this data is interconnected. And so when I attach this to a specific floor of the building, level 4 here, and I'm looking for a specific unit, all of this gets related in the twin. So the next thing that I wanted to talk about was the ruling engine. So I mentioned as a lot of this telemetry is flowing in, one of the really important things for Willow is to action that data. So not just make sure that it's organized in this in the digital twin and has context, but also making sure that it can provide actionable insights and action eventing for users to better perform their work. This is a quick snapshot of our ruling engine. In this instance, what I've mocked up here is actually an occupancy example where we've got several occupancy sensors. This is a kind of a visual programming. It allows our customers to generate their own actions. And so they're able to take the output of these occupancy sensors, add a count, and maybe this is monitoring a lobby. And with COVID, they want to make sure that if that count of these occupancy sensors in the lobby exceeds a certain value, go ahead and notify someone. So I'm going to take the output here, do a quick count. I can trigger an actual Azure function. So this programming language, you can actually inject JavaScript functions that trigger. And the output of that function is generating an actual insight in our platform. And so that insights pane that we were looking at the beginning could trigger an alert or an alarm to someone to go investigate, maybe the density of that area has exceeded what its threshold has been set to be. And the last item that I wanted to highlight in the platform before we jump into kind of some of the behind the scenes is all of this data ultimately gets trended, aggregated, and surfaced. And so when we look at our data warehousing solution and how the user can start to investigate some of that data, a lot of times what they're interested in is comparing how maybe one building compares to another building in their portfolio, or how one portion of the building has trended over time. So what we're looking at here is actually live thermal metering. So all of the AC units that serve the tenants in this building have metered condenser water that's being sent to them. And so if I'm interested in being able to maybe offer that data up to my tenant, again, this is the power of Azure Digital Twins, is all of that data has context to it. And we'll talk about the ontology in a little bit, but the way that data can be presented and even shared with the tenants, the end users are wanting more and more data, similar to how they have in their smart homes. They want their smart buildings to present them data so they can make better data-driven decisions. And as we trend all of this data, one of the goals of the digital twin, again, is to be able to aggregate it and present it in nice, clean ways. And this is just one example.
Thanks, Rick. That was awesome. I would like to ask you a question. Based on the demo, we have seen multiple sources of data merge into one digital twin view of the building. I have seen there the BIM data with all the building components, all the BMS data with the HVAC devices. I've seen live data from IoT Hub and telemetry, ticketing. Could you please walk us through how do you manage and keep track of all of these data sources, and how do you query them? So essentially, what are the benefits Azure Digital Twins provides to WillowTwin platform?
Yeah, it's a really good question. So one of the ways that Azure Digital Twins helps is it really gives us that balance of flexibility and scalability. So as we look to make sure that as all of this equipment and systems and interconnectedness and data, it has actual meaning. And so you can compare it. What's really important for us is the analytical aspect of all this. And so if we look at a DTDL or digital twin definition language model of an air handling unit, we want to make sure that that's consistent across the building, across the portfolio, across the campus. And so when we classify something as an air handling unit, for example, even though it might be named AC unit in one building and DX unit in another building and rooftop unit in another building, we know that it's performing a similar function. And so we can drive analytics and insights based on the fact that we know that at the core of the ontology, it's been classified as an air handling unit. And the same applies for all of the various data sources that go into the twin, whether it's the geometry, the actual live data with the BMS points and capabilities, documents. That's one of the things I didn't touch on, but all of the documentation that gets generated during a construction phase or an operational phase, whether it's O&M manuals, product manuals, they all need a home as well. And so they can be stored in the twin. So the fact that Azure Digital Twins can help make those interconnections without having to kind of redeploy all of these many-to-many join tables in that kind of traditional SQL sense has been amazing. And it's allowed us to scale much, much faster.
That's great.
And then, Rick, I really, really loved that full walkthrough, especially for the view for these property owners, the facility managers. And, I think of all the folks who are watching now, if they're architects and developers, would love to see that behind the scenes. Could you jump in, show that architecture, the services and products used, and then jump into VS Code? I think we're all really excited to see that.
Absolutely. So yeah, before we jump into kind of how we've leveraged Azure Digital Twins SDK and put this solution together, I think it's always nice to look at the actual architecture. So this is a very high-level overview of the platform here, but if I just kind of walk through from left to right, on the far left, we have the what we call the edge. And so this is the actual on-premise systems. And so we deploy an IoT Edge gateway that's running the IoT Edge framework that Microsoft offers. We can deploy from our cloud anywhere in the world different applications onto that Edge device. And that device could be a hardware device. It could be a software device. We'll show in a little bit an example of Azure Stack Edge, which we're running on some customer sites. But those apps can do things like protocol translation. We've got a couple examples here of BACnet and OPC-DA or Modbus. But we can also perform things like edge analytics and deploy edge streaming analytics or machine learning, different functions on the edge, which really allows us to make sure that we can optimize the data that's being sent to the cloud versus being fast and actionable at the building. What's really important for us is that connection from the edge to our cloud gateway, which is, again, built on Microsoft's IoT Hub technology. So this secure connection that happens here allows us to make sure not only that we can scale to different sites quickly, but also make sure that all that data that's entering our platform is entering it in a secure way. Once the data hits IoT Hub, we do a number of things. We can trend that, so it can be stored in our time series database. And we can also use it to update the twin. And so what we're showing here is being able to do live data transformation via Azure Streaming Analytics, which can then output to an Azure function that can actually update all of the twins in our Azure Digital Twins instance. So if I've got live temperature telemetry coming in, for example, for a temperature sensor in a room, I can actually have that cascade and update other twins in my graph, in my digital twin. That's really powerful for us. The fact that Azure Digital Twins has eventing built into it is really powerful and something that we're really excited about. We looked at insights and other ticketing services that the platform offers. All of those services ultimately get orchestrated via our WillowTwin orchestrator and then surfaced to either our UI, which could be either web or mobile applications. We have both the command platform that we looked at, but we also have tenant experience and workplace experience applications to really optimize the end users' interactions with the facility. And then what's really important for us is to allow our partner ecosystem via the marketplace to build integrations with the platform. So we at Willow are really adamant that our partner ecosystem, there's amazing solutions on the market. And we want to sort of have the 1 + 1 = 3 scenario where we can have a best-in-class fault detection platform or best-in-class visitor management solution. They can hook into the twin, and both of our solutions can offer our mutual customers a better experience.
That's great, Rick, to see all the products and services that are used with WillowTwin. Could you deep dive into the code itself and how the software developers can start building?
Absolutely. Yeah. So this is where I get excited. The work that we've collaborated on with the Microsoft team, really the whole IoT team, rolling up our sleeves, looking at how we can leverage their SDKs and APIs to work with not only Azure Digital Twins, but IoT Hub, and kind of the interaction has been a really powerful experience. And so I'm going to just kind of walk through a journey of kind of how we started from day one all the way up to building the WillowTwin. And hopefully, if there's developers out there or software architects that are looking to do the same, we can offer some quick advice or by all means, reach out if you get stuck and are looking to do something, because chances are we've encountered the same questions as we've gone on our journey. So when working with Azure Digital Twins, the first thing to understand is you want to first build up your digital twin definition language models. And so one of the very important aspects that Willow has adopted is the open source real estate core ontology that the Microsoft team just released. And that ontology allows us to have not only a common language, but also kind of that common, what we say is the common dialect as others. And so when we're looking to integrate our platform with other platforms, it's really important that we can do a quick handshake. And if we're both speaking this real estate core ontology with a DTDL models, we can quickly understand that, hey, if you're talking about an air handling unit and I'm talking about an air handling unit, we all have the same properties and understand the same relationships when working with that. So the example I have up here is actually an example from the real estate core ontology. This is an example of that air handling unit that I was talking about. You can see here that there are many different properties that are associated with this, as well as relationships of how this air handling unit can potentially be fed air or water, how it relates to space. Again, kind of that graph topology is really powerful as we look to traverse the graph and understand how different equipment and spaces relate to each other. One of the things that we've done is extended this air handling unit. So whenever we have a case where we've adopted this ontology, but Willow is looking to add to that base class, all you have to do is extend that model. And so here's an example where we've actually extended a rooftop unit. So a rooftop unit extends our base class of an air handling unit, but it also extends the real estate core base class of rooftop unit. This is what a small nuance, but it's actually extremely powerful, where this kind of diamond-shaped inheritance of these models allows us to do some pretty powerful analytics. It's not just kind of a simple class hierarchy where you can adopt models from a single parent. You can adopt from multiple parents. Those parents can have a common parent themselves. It really allows for what we're driving towards, is that powerful search-based experience. And so what I'm going to walk through here is, once you've got these models developed and created, in our case here, the real estate core ontology has well over 400 models. In our library, we've extended those with another 400 plus models. So we've got, I think, over 900 models that we want to ultimately load into our Azure Digital Twin to form our core ontology from which twins will actually get created. And so I'm going to just run through an example here of working with the models. And so one of the first things that we do is validate the models. And that just is a simple DTDL validator tool that the Microsoft team has actually produced and shared on GitHub. And so what's really important for this step is, before you load them into your digital twin, you can quickly validate them. The tool has a parser built in where you can quickly parse through, in our case, close to 1,000 models in under a second. So it's powerful before you go through the process of importing them into your twin to validate them. That validator tool, in our case, as I mentioned, we've just adopted as a submodule from GitHub. So if you're curious, check it out. It's on GitHub, as I mentioned, and we've adopted it here. And so I'm going to go ahead and run that tool. In our case, you're able to export it as an actual executable. So in this case, you can see here, I've got an executable in my ontology. What this tool does is actually recursively goes through every JSON file within the subfolders. So as I mentioned, within these two folders, the rec folder of their 400 plus models, our Willow folder of our 400 plus models. It's going to parse through all of those and validate that my DTDL models have been written correctly, they inherit from each other correctly, and that there's they can be properly uploaded. And so I'm going to go ahead and run this tool. And you can see here, in less than half a second, I read 841 files. I found 1,993 entities. So all of the properties, relationships, those were also validated as well to make sure that they adhere to the DTDL standard. In this case, all my files are valid, and so we're ready to start importing. So what I want to walk through first is how we started importing. So the Azure Digital Twin offers a full set of APIs and SDKs, which was great for us because we can have our development staff focus on building the upper layer stack, and adopting that platform as a service from Azure Digital Twins has been amazing. It's saved us, we estimate, in just the 3-4 months that we've been working with the Azure Digital Twins platform, it saved us well over 200 hours. And the reason is because we've been able to adopt that platform as is and focus on writing our API layer on top of it. So one of the first things that we developed was our ability to import the models. And so we created an importer tool that was able to import the models, as I mentioned. And so we can see here that we've got this import twins task that I'm going to focus on. And one of the things that we've done is written a little tool. And so let me just minimize this here. One of the first things that we do when we load in the models is it's really important that because these models have dependencies, as I mentioned, through that inheritance, if a model depends on another model, it needs to know that that one exists in the platform already. So what we actually do when we've built our code for this importer task is built a little dependency graph prior to uploading. And so we grab all of the items from that library, that ontology, all the JSON models, create the dependency graph, parse through the files, and then ultimately upload them into the Twin. And so if I just start from the top here, kind of what's happening when we first start importing models, I'm going to, as I mentioned, search for my directory, grab all the JSON files that I find, and generate a list of those files. If I parse through those and I find an existing model, you can see here that we don't change it, that it already exists. But if we do find a new one, we can go ahead and add that in. When I run that, I am calling the model parser. So that same parsing library that the team offers, we're calling as well. And then we go ahead and run the import process, which runs as an async process. And so I've actually added one additional model to my library. So I'm going to go ahead and walk through that process now by calling that tool. And so this is our command line interface tool that we've developed based on that code we were just looking at. And we passed it in a couple of statements, just the environment that we're looking to upload it in, as well as the folder to go search for new models in. I'm going to go ahead and run this now. Great. So it just went through and found that 840 models had already been imported, so it skipped them. But you can see here that I added one new model called rooftop unit with reheat. And so again, it finished that import. And so now in my Azure Digital Twins instance, I've gone ahead and uploaded and have a total of 841 models added to the library. Again, one of the things just for the developers out there, it's really important as you're developing that logic for importing models to make sure that you understand how those DTDL models inherit from each other to make sure that you can develop your code to account for that those dependencies. So as I mentioned, we developed a bit of code to develop that dependency graph. So you can go ahead and upload models, as I just demonstrated, 841 models with all sorts of different interdependencies all at once. What I want to jump to now is the actual API layer that we've developed. So this function ultimately is calling the Azure Digital Twins SDK. Our platform is mostly built on the .NET framework, and so we've used the .NET SDK. And so one of the things that I'm going to jump to and show now is our create models SDK call. So in that demo that I just showed, ultimately we're calling this create models, and working with the SDK is extremely easy. This get client call really just grabs the environment settings and credentials for interacting with the ADT instance. And then we make a create models call and load in the actual JSON of the DTDL model. And so this call here is how we use the create models SDK from Azure Digital Twins. All right, so one of the things that was kind of next up in our development journey, we said, all right, now that we've got all of these models loaded in, we want to start creating twins. Twins have properties associated with them. They have relationships to other twins. It was really important for us to be able to deploy this in a scalable fashion is to actually first, before importing twins, to export templates. So one of the things that we developed as part of this application was the ability to look at all of those 840 models that I just uploaded and generate an actual Excel template library. And so we knew that as our team is needing to receive data from multiple different sources, that we can make sure that they're generating that data in a proper format so it can easily be uploaded into ADT. And so what we've done, again, just kind of jumping back over here to our various tasks, is we have the ability to export templates. So I'm just going to take a look at this code a bit here. When we call the export twins, one of the things that we do is first we grab all of the models that I've loaded in for a particular site. I parse those models, and then after parsing those models, I want to actually generate my Excel templates, and I'll show an example of what the output of one of those looks like here in a second. When I grab all of the models, when I parse that JSON in, it's really important for us to take each one of those properties that I found and insert it as a column header. The complexity with taking JSON and putting it in a tabular format is you need to have sort of a mechanism in place for how do you deal with complex objects. And so this exporter tool takes that into account, and it's something just as you're developing solutions that's really important to think about is how will you take a complex object of a DTDL model and make sure that you can read in all of the subproperties and the subproperties in an efficient fashion. And so that's what our tool does here. So if I look at an example of what one of those looks like, I'm going to go ahead and jump to that now. So this is the output of the Excel template process. And so all of these column headers have been outputted by that function that runs. And so the first thing that we export is the model where we, when we're looking to upload, in this case, I've the DTDL model being references for a building. The model references that DTDL model, a unique ID, and then all of these remaining columns are the various properties and relationships that we read in. This is a good example of how we've addressed the challenge of dealing with complex properties, where we've added in a dot notation separator. So as we parse in this file, when I reach a dot, I can find a subproperty. So I have an object called coordinates that has two subproperties called latitude and longitude, and we're able to read this file in through our import twins process. So the next thing that is really important for us is, once we've got these templates exported, we've filled them out with the data. Again, properties, relationships, we're ready to start importing these, start creating some twins, start creating our graph. And so I'm just going to walk through an example of how we've implemented the Azure ADT SDK. The first thing I want to show is our import twins task that we've written, and just kind of highlight, again, some items to watch out for as you're developing this code logic. One of the first things I actually should have mentioned at the start was when it's working with the SDK is as easy as adding in the Azure Digital Twins to the to your library here. Once you've added that in, I'm just going to walk through our logic here. And so when we call our import twins function, the first thing we do is get all of the models. So when we read in that Excel file, that first column that I talked about was showing which DTDL model ID to go find. It reads in all of those and fetches them. One item to think about as you're developing this code is when you're working with a graph, it's not just a nice tree structure where you can import the parent and then have the child relate to the parent. You have all of these interdependencies. And so for us, we've got the logic to actually load in models, not just from a single Excel file, but an entire directory worth of files. And so if you have different models that depend on each other, I can go ahead and create all of the twins first. And then what happens is we create the relationship second. So you create all of the nodes in the graph. Once all the nodes are created, it allows you to seamlessly create relationships, and they can be tree structure or cyclical or however you want. And it imports very gracefully, as opposed to encountering an error where you're trying to create a relationship to a twin that doesn't exist potentially. So just kind of walking through this code, once we load in all the models here, the next thing we want to do is start reading in all of the properties. And so we're going to parse that file. Once we parse that file, we're going to head, again, the first thing we're going to do is check if a twin exists. This is another good little learning item is, for us, we wanted to check if a twin exists. We're actually going to delete that because we're going to upsert it with a new twin. If you're trying to update a twin that already exists and you need to potentially remove a relationship, you're going to encounter an error because you're going to potentially orphan a relationship from a node to node. So we check if the twin exists. If it exists, delete the relationship, create the new twin, create the new relationship. So this is just a going through that process of generating all of those twins and relationships. The first thing I'm going to do is create all of the twins. And so this function here, again, calls our API layer. So if I jump back over to our API layer, and now I want to check out my add or update twin. Again, it's an upsert. It's as simply as calling the create digital twin SDK statement here, passing in the twin ID, as well as the a JSON representation of the twin. just jumping back over to my command prompt, taking a look at that in action. In this case, I'm going to point my tool to read in an Excel file, the one that we were looking at. So I'm going to go ahead and pass in the import twins statement and point it to a directory. Again, this directory can have one Excel file. It can have many Excel files. In this case, I've got a single Excel file that I'm going to go ahead and read in. And you'll see the logic happening here, where I'm first going to load in the models. Now I'm importing all of the twins. And so you can see here that I found 8 twins. I created relationships. These are the various relationships connecting this twin to other twins in the graph. And so I've made connections to 8 different nodes. And it looks like we've got some error catching here. So in true live demo fashion, the boiler twin that I've created is throwing me an error, and I can go ahead and check out how I need to update my potential Excel load sheet to fix that problem. All right. Once I've got my twins uploaded, I've got my relationships created. One of the things that's next up for us is to actually interact with your Azure Digital Twins instance. That's what we're driving towards. And so there's a really powerful query SDK and query API that the team has developed. It's being updated literally every week. And so check it out. The recent updates, such as being able to do projections and counts and things like that, has been really important for us as we look to streamline the speed, as well as make sure that our team developing our UI can efficiently activate and work with the API. So I'm going to jump over to my API again and just show you how easy it is to work with that query language. So if I want to do something as easy as fetching all of the twins in my graph, here's a quick little function where we've passed in a query statement. Just select all, select star for my digital twins instance. And again, I'm going to just call that same SDK, parse it, and I can return all of the digital twins in my instance. What's great about working with the SDK is it allows us to basically paginate through all of the results at our API layer. And so we can choose to our users how we want to potentially offer that up in terms of their pagination experience. If I want to have a much more complex query, we can do that as well. Check out the documentation online. They give great examples of how to work with the query language. It's very SQL-like, so if you're used to working with SQL, you'll pick it up very, very fast. But this is how we call the query SDK. Again, when we want to query twins, we call our client, pass in the query statement, as well as the actual query string that we want to run on it. And in this case, we're going to head and just, again, all of the twins that it fetches are returned to us in this item here. Very, very quick, as you can see here. It's less than 10 lines of code to start working with and interacting with your twins. It's a pretty powerful experience. And so for us, this statement right here gets called as I walked through that demo experience all over our UI. Just different types of queries we want to pass in, filtering experience, being able to have relationships. And so I'm just going to highlight a few of those back over here. If I jump to my dashboard, again, every time I'm clicking here, it's making a call to ADT. And so if I want to do a search for my floors, I just did a query for all my floor models. If I want to jump to level 4, pull up details about level 4, again, it's hitting that query API that we've developed. When this loads, I can start to interact with what are all the different entities on this floor. I've got assets, I've got tickets, I've got insights, and that query statement is, again, behind the scenes. And so as I want to search, again, I'm passing in a query statement for show me all models that are related to the mechanical water side and show me all DX units. And it's going ahead and fetching. In this case, it found 3 DX units that have the name AC46, 47A, and 47B. That's all powered by that query statement that I've just passed in. Being able to say, if I find a match of this model type, in this case, a model type might be called DX unit, go ahead and fetch me all the results only for level 4. And so these are really just hops in the graph, traversing the graph. It's been amazing for us to work with this and streamline how our UI can add features. And so we're doing a feature drop literally every week because our product team has been really leveraging the powerfulness of the graph, of the query language, being able to quickly add new features in. The last thing I wanted to highlight again is just a little behind the scenes is a bit on Azure Portal. So all of this data that's coming in, as you can see here, we've got an AC unit with a fan speed currently at 75% and a 73.1 Fahrenheit supply temperature. That's all driven from our edge to cloud telemetry that's being fed in, which is our running on our IoT Edge connector. And so if I jump over to Azure Portal here, what I've got pulled up here is our actual Azure Stack Edge gateway. So this is a first-party Azure device, amazing security built in. It's been amazing to work with the Azure Stack Edge team to develop this product and how it can work with the real estate industry. What I want to show here is the fact that we've taken this box, it securely connects to our cloud, and we just deploy IoT Edge modules onto this. And so in the case of this Azure Stack Edge, you can see here, these are really just containers running on it. I've deployed we actually have 2 separate backnet apps, one that does our scanning and one that does our actual data pipeline from the edge to the cloud. And then we have the actual IoT Edge runtime and logging and analytics running on that device. So if anything goes wrong or connection issues, we get notified immediately.
Rick, that was really, really exciting to see you go through that full experience for the developers and architects who are working with WillowTwin. I'm super excited that you're here and Alina's here to talk about this because Azure Digital Twins is a whole new space. And so it's exciting to have, a real world example of this. And so it's one thing for us to talk about our products, but it's another thing to hear it from you, Rick, especially when you said you saved 200 dev hour time estimated, because that's exciting because that allows you to focus on other areas of your solution. So I'm over the moon happy about hearing that. So I know there's other people who are excited to learn how to get their hands on this, how to play with this, and some resources on how to get started. Rick, do you want to cover the first part about the developer portal with Willow?
Yeah, absolutely. And yeah, just as you mentioned, all that time that we save really allows our subject matter experts in these complex topics to focus on what they do best, which is developing the ontology. Our developers can do what they do best, which is developing our business logic. If you want to check it out, jump to developers.willowinc.com. If you want to join our developer community, just shoot us an email, developers@willowinc.com. If you're a third-party solution provider, also working in the IoT space, the real estate space, we'd love to have you join our marketplace. And if you want to join the team working with this fantastic technology, just let us know.
Wonderful. Thanks, Rick. And then, Alina, where do people go if they want to learn a little bit more about Azure Digital Twins?
Yeah, we have created a simple alias to remember, aka.ms/digital twins. You have lots of material here to learn. We have quick starts, tutorials, many the how-to guides. And also, if you have feedback or any feature request, we'll love to hear from you. This is also Digital Twin /support. And we invite you to join our journey. And we are very excited that
I'm excited too. And if you're interested about upskilling on Azure IoT as a whole, we do have Microsoft Learn, and it's hands-on tutorials, self-paced, sandbox experience, so you don't have to have an Azure subscription to get started. So definitely check that out. And we have some more links and resources that will be highlighted in the landing page and then in the description below. So thank you both, Rick and Alina, again for being the guest speakers and sharing your insights in this space. It's, like I mentioned, it's really new. And so a lot of people are really interested in, what are the best practices? What is the space all about? So exciting that to have both of you here. So thank you so much for joining.
Yeah, thank you.
Yes. Thank you.
And then thank you for viewing, everyone who's watching. We really appreciate you joining in and sharing your feedback. So we hope that all of you are going to enjoy and look forward to working with WillowTwin and deep diving into Azure Digital Twins. So thank you, and we wish all of you a great day.